All right, everyone. Hi there. I just wanted to talk about clarify a few conceptual misconceptions about superconductivity. Superconductivity is all about the conductance of electrons, electrical energy, at super low temperatures, at very low temperatures, like close to sub-zero, not sub-zero, but like 0 degrees Celsius, in most cases. The ability of certain elements, such as niobium, which is niobium, and then thallium, zirconium, thallium, niobium, and then technetium, uh, and then zirconium, lead, and mercury. Surprisingly, mercury and lead. Lead is also like very, lead is able to. Lead is able to do that. Lead, the ability of these elements such as niobium, zirconium, technetium, and lead, mercury, and thallium, Th, symbol Th. These elements, they're able to conduct electricity at super low temperatures, which means that they can conduct electricity with zero resistance, where the resistance is less than or equal to roundabout less than equal to zero, greater than equal to zero, roundabout 0 ohms. Okay, so this is what you need to realize, and this is however, it happens at DC voltage only, and I'll talk about DC voltage and AC circuits a little bit in detail. DC voltage is more conducive. It's what's used in industrial scale, to actually deal with and generate and perpetuate all sorts of superconductivity phenomena. However, if you are using AC, which is I equals I naught sine 2 pi f t plus theta, if you're using that, then you'll need a jump start voltage. A jump start voltage is what you need in order to kickstart the occurrence of superconductivity at AC. So this is why we use DC, not AC, because AC requires, and there can faults or efficiency problems which can take place when trying to use AC current to generate superconductivity for elements such as zirconium, thallium, technetium, zirconium, lead, mercury to carry out this, and they're very useful. Superconductivity, is very useful, and obviously the phenomena such as resistivity, like rho equals R equals rho L over A, conductance, and conductivity. All of them are part of superconductivity, but all of the electrical conductance is taking place at sub-zero temperatures. So I hope you understand where I'm coming from. Thank you very much for learning about this misconception, and that's pretty much it. Thank you.